Hello everyone, welcome to my channel Learning on the Go. The topic for the day is tree ADT. So talking about the tree ADT, tree is a nonlinear data structure. So the objective of this particular video is let us see what a tree data structure is and the basic terminologies that are associated with the tree data structure and the different tree traversal algorithms. So as I have already said, tree is a nonlinear data structure. Since the name conveys it is a nonlinear, which means it doesn't follow any sequential or contiguous or continuous hierarchy. It is the elements are stored in a non-linear pattern, non-linear hierarchy. So the talking about the real life examples, the family tree. So the parent, grandparent, parent, then their children. So this family tree is again set to follow tree data structure, and the table of contents in any particular book for that matter is again set to follow a tree data structure, and the inheritance hierarchy is again say there are parent node and child node where it extracts the features, methods and attributes from the parent class. It is again this inheritance in a object oriented programming is again a tree hierarchy, tree data structure. And the computer file system, the way in which we store the folders and subfolders, is again said to follow a tree data structure. And talking about the machine learning concept, that is decision tree, it is again said to follow a tree data structure. So these are some of the real-time examples or real-life examples that can be associated with the tree data structure. And as I was telling, the computer file system is again a tree data structure, whereas the all the directories, folders is said to be have a root that is the simply talking about the layman level, it is my computer. From there, we can traverse to several other or different folders. We have a separate folder for documents and settings, and separate folder for the installation files, that is program files, and a separate folder for my music and separate folder for downloads. So this is how the files are being located in a computer, right? So talking about the table of contents of any book for that matter, here the example is say Java software structures book, right? So introduction part will be different. From there we'll traverse to several be it Java introduction or data structure introduction or algorithm introduction, and there is a different uh, branch of analysis of algorithm that talks about the space and time complexity, and we have a separate thing called index, whereas from that index we can traverse to or move on to the different chapters of the book. And talking about the terminologies in a tree, so the first node, which from where we build our tree, that first node is called the root of the tree, right? So there, a tree will have several nodes. Node is nothing but the uh, proper place or the proper element where we store the value. The detail or the data where we store is called a node. So in order to connect two different nodes, a line will be used. That line is technically uh, called as an edge, right? So in this case, this is a root node of the tree, and in order to connect several different nodes, we have a line connecting these nodes that is called as edge, right? So a tree can have several other subtrees, which is again said to follow the thumb rule of a tree. See, in this example, we have a different subtree and a subtree which has only one node, two subtrees which has only one node, and a different subtree, right? So a node is the place where you store the values, that is an element in the tree. Edges is nothing but the connecting lines between two or more nodes. Root is the origin, the first element that comes in while constructing a tree is called as the root of the tree. So as I was already telling, there is only one node for a tree. When talking about an empty tree is one tree which do not have any node or an edge, right? So this is a picture of how a basic tree will look like. And talking about the further terminologies, parent or predecessor. Parent or predecessor is the previous level, say from where I started from. is called as a parent, right? The node which is located in the above level is called as parent or predecessor. Child or successor is that nodes that falls to the next level of mind is called as a child node or a successor node. And sibling is nothing but one or more nodes which are connected to a single parent node. It is called as sibling. That is, nodes which share common parent. A single parent is called as a sibling. Ancestor of a node is nothing but its parent, right? The parent of its parent. Parent and parent of its parent, like parent, grandparent kind of thing. Descendant is nothing but the children and their grandchildren. The one which follows in the next level, starting from me, is called as descendant node. So the next set of terminology is nothing but a leaf node and an internal node. Leaf node is nothing but the node which do not have any children. A node with zero children is called as leaf node, and the node which has children is called as a internal node. So in this case, whereas the nodes which are colored blue do not have any children, that is the nodes with zero children, and we call them as leaf node. Whereas the nodes which I have shaded it in yellow, they have children, maybe more than one or more than one child. Here, this node has one child. This particular node has two child, and this node has three child. Similarly, this node has one, and this node has two children. So the nodes which have a child node is called as an internal node, and the nodes which do not have a child node is called as a leaf node, right? So here is a simple question. Maybe you can think and answer. Does a leaf node have any children? So you can think of it, right? So does the root node have a parent? Root node of the tree, does it have a parent? You can think of it. And how many parents does every node other than the root node have? So how many parent does every node other than the root node have? Is it possible to have one parent or more than one parent? So here I have put forth some basic questions with what we have seen so far, and you can try answering those questions. Now let us move on to the next set of terminology, that is height of a tree. Height is nothing but you'll traverse the path. The path is nothing but, say I have a source node and a destination node, and the route in which you traverse, the connecting edges, you'll jump or hop between the in between nodes, right? So that traversal, that path you traverse is called as a path, right? In order to traverse from a source node to destination node. So similarly, length of the path is nothing but the number of connecting edges. Number of edges you have to traverse, you have to move across in order to traverse from source to destination is the length of that path. Talking about the height of a non-empty tree. An empty tree cannot have a height because it doesn't have any edge or node. Talking about the height of a non-empty tree, the starting from the root node of the tree until the longest leaf node. Longest leaf node is which falls to the uh, later levels, not to the earlier levels. Whichever path is the longest path, that path is calculated as height of that particular uh, full tree, complete tree, right? Say if my tree has only one node, that is only the root node. A tree with only one node means their height is said to be -1, right? Now, here with this picture, we can assume that this is the root of the tree, and talking about the longest leaf node, say these are the leaf nodes. The one that is colored in blue are the leaf nodes. So talking about C and D, their path is only one, right? So talking about G and I, their path is only two, right? Talking about K, L, M, and N, their path is three. So the longest leaf nodes are K, L, M, and N, whose path is 3. So the height of this complete tree, full tree, is said to be 3. Right? So this is how you will calculate height of any particular tree. Then talking about the levels. Level is nothing but the hierarchy or the predecessors uh, of any particular node, whereas the level is initially numbered 0, and as it moves forward, it will be incremented by 1. Right? So this is how it will be calculated. You can define it recursively. Say, assume that the level of root node is 0 and the predecessor's level will be incremented by 1 with respect to the previous uh, ancestor's level, right? See here, I'm putting forth again a simple question. What is the level of a node in terms of path length, right? What is the level of a node in terms of path length? This is question number 1. And the next is, what is the height of a tree in terms of levels? What is the height of a tree in terms of levels? So I have put forth two simple questions which you can try to answer. Right? So this is how you'll calculate level. So all the root node will always be in level 0, and the further predecessors will have their level incremented by 1. So this level 0, this root node has 4 children, child node, whereas each of them falls in level 1, and only 2 of its children has child node, whereas their children, all their children falls under level 2, and among this fellow, only this fellow has a child node and he falls in level 3, right? They cannot be jumbled. They'll be in same level, right? So talking about this particular node, his sibling is shaded in yellow. So the node which shares same parent is called as child node, right? Then talking about subtree. Subtree is nothing but subtree is again a dissonant node which again has a tree structure starting from itself. So subtree is again a tree itself. It is said to follow the properties of the tree as a whole. Whatever rule that is applicable for a tree, it is applicable for a subtree also. Similarly, a node or a complete tree can have any number of subtree. We do not have any restriction while constructing a subtree, right? So in this case, say E itself is a subtree, right? The root is shaded in red, where E itself is a child node. E itself is a subtree. From there, we have several other subtrees. Say in this case, we have 3 subtrees starting from the subtree E. So any subtree can have any number of subtrees for that matter. And talking about the next terminology, that is nothing but degree of a node. Degree is nothing but number of edges that a node has, that is no, a node that has, right? So this in degree can again be calculated or categorized into in degree, out degree, whereas that is only in graph but not in uh, the trees. So degree of a node is the number of children that it has, right? So the degree is the number of child node that I carry or possess. A simple tree can have any number of children. So it is the number of children. Degree is the number of children. Talking about the degree of a tree. So degree of a node is different from degree of a tree. Degree of a tree is the maximum of degrees a tree's nodes have. Any particular trees, degree is calculated with the maximum number of degrees, maximum number of child nodes, right? So maximum number of degrees, the complete trees nodes that carry is the degree of the tree. So these are the basic terminologies that we have to know for sure while constructing a tree, right? So talking about the tree, here this fellow talking about, let us traverse from lower level to level 0. So F, how many children does K, L and M have? Since they are leaf node, they do not have any children, so their uh, degree is 0, and the degree of F is 1 because it has only one children. The degree of B is 2. Why? Because it has 2 children starting, that is created from B itself. Talking about A, it has 4 children. So this is how the degree of each node is calculated, right? So these are the basic terminologies about that we have to know before kickstarting to know what is a tree data structure. Thank you. See you in another video. Thank you.